Hello friends, today I will discuss the comparison of three-phase induction motors and operating modes of three-phase induction motor. First, let me consider the comparison between the single cage and double cage motors. Here, parameter is defined common for both the motors and then their values are compared. Parameters: starting current in case of single cage three-phase induction motor, it is large, whereas in case of double cage induction motor, it is small. The starting torque in the single cage induction motor, it is less. In the double cage induction motor, it is large. And the effective resistance of the rotor is less in case of single cage three-phase induction motor, whereas it is more in case of double cage induction motor. Heating in case of single cage induction motor, it is less, and in the double cage induction motor, it is more because the resistance is high. Next, pullout torque is large in the single cage induction motor, whereas it is small in the double cage induction motor. And cost for the same rating of the motor, single cage induction motor cost is less, whereas the double cage induction motor cost is high. Copper losses in case of single cage induction motor, it is less, whereas in the double cage induction motor, it is more. Efficiency of the single cage induction motor high, whereas in the double cage induction motor it is low due to the high effective resistance. Operating modes of three-phase induction motor. So this is the torque versus speed, torque versus slip characteristic. And here, from here to here, the speed is 0 to synchronous speed, that is n is maximum ns, or it should be operated between 0 and less than ns. In that case, the induction motor mode of operation is called motor operation, that is motoring mode. So the slip range is 0 less than or equal to slip less than or equal to 1, means slip range is 0 to 1. And here this is the stable region, that is full load operating point, means this is the full load operating point. So from here to here, this is the stable operation of the induction motor. And here the slip of the induction motor is 1 and the speed of the motor is 0, that is rotor speed is 0. Under that condition, the torque produced is called the starting torque, like this. Similarly, the maximum torque is this, that is Tmax, that is also called breakdown torque. If the induction motor rotor is coupled to the external prime mover and in such a way that the rotor speed is more than the synchronous speed, in that case the induction motor works like a induction generator or in the generating mode, then the slip becomes less than 0, that is minus. So S becomes minus, slip becomes minus. So that is here, the characteristic is like this. This is the ns. So when it goes to the right side, the speed will be, rotor speed is more than the synchronous speed. This is due to the external prime mover connected to the rotor of the induction motor. So under this condition, slip is less than 0, that is slip will be negative, and it generates the power and supplies the power back to the mains. Similarly, slip also direction is like this. It will be minus. Less than 0 means it will be minus. Similarly, if the three-phase induction motor, any two input terminals are interchanged to the main supply lines, then the direction of the rotor is opposite to the rotation of the stator magnetic field. That is, it follows the negative phase sequence. In that condition, the slip will become more than 1. So under that condition, the curve comes to the left like this. 0, this is slip is 1, and it goes on increases, and it can reach up to 2, and the speed that we write in this direction we call as minus direction. That is, rotor speed will be taken as negative because it's moving against the direction of the stator magnetic field. So under this condition, the slip of the machine, induction machine, is more than 1. So then it is called the braking mode operation of the three-phase induction motor. So in this case, in the generating mode, externally capacitors are connected to the induction motor so that it provides the sufficient reactive power so that it provides the magnetic field to the rotor conductors to work like a generator.